Day 22 in the journal Journey of Learning. Let's continue configuring our first router in this network project, and we're going to continue by adding configuration for the network management interface, WAN, LAN, and redundant connections, as well as DNS, the network domain, and routing. As always, we first began by scripting our configuration, and let's get logged into the router. As previously, we've added security, and as we can see, we're advised that only authorized personnel should be logging into this router or connecting to this router, and that access is restricted. Here we are prompted for our credentials, which we added in our previous video. And again, this is our security measure. You want to get into enable mode? Guess what? Security measure. So we have layers and layers of security here. Let's go into configuration mode. And so we're ready. Let's clear the screen. I like to keep the screen nice and clean. And so first, let's go with the network management interface. This will be the IP address of the device, which we will use to connect to and log into the device in order to make maybe configuration changes or various updates to the router itself. So, and we do that by creating a loopback interface. Give it a description so that you will know, if you look into the config, you'll know exactly what this interface is for. And we place it on our network management subnet. Let's copy and paste that. So now we can manage that device. Next, let's configure our WAN interface. This is the interface that will be connecting to the internet. This is actually the first of two interfaces that will connect to the internet. And we've placed it in the IP address or in the subnet that leads to the internet. And we're going to NAT this as well. So we're telling the router that the description of this is WAN link. Place it in this subnet. We're going to NAT this on the outside, and we have the duplex and speed. Next, SVI. So we have a switch virtual interface. That interface, instead of acting as a switch port, will act as a switch virtual interface. And as you can see, it is also in a VLAN, which is an uplink to the internet. And this one is natted on the inside. The natting really only takes place on the outside here. But then we have NAT, which is for the inside. So inside, we're meaning our inside addresses, our private IP addresses. Where here, we're going public. So let's place that configuration as well into the router. And next, serial interface. This is being used as a redundant connection so that if one portion goes down, it can have access to a different link. So what will take place if the circuit goes down? This is a link between the two routers. And so if one of the circuits goes down, then our traffic can travel over this connection to the other router and get to the internet. So this is redundancy here. And we're using a serial connection. Let's clear this. It's getting a little crowded. Now I just want to come out of that. Next, we have our DNS domain name. The domain of our network is ATL Fusion. And remember that comes into play with certificates and etc. to authenticate, is this the right resource that you're connecting to? Next in the router, we want to configure our DNS. I do not have a DNS server on site here, so I'm going to tell the router to use public DNS to resolve URLs to IP addresses, so that when you enter such things as Microsoft.com or Cisco.com, Juniper.com, BBC.com, and etc., it will be able to use that server, the DNS server on the internet, to translate that to the actual IP address and location and reach that resource. So that is what that is for. Lastly, let's configure a dynamic routing protocol. So the dynamic routing protocol will dynamically keep track of routes that are active, and then routes that are not active, it will mark them as, say, bad, and then it will remove that route so that we can have the information that we need to reach certain addresses. So we're using EIGRP routing protocol, and I'm telling the router that these are the networks that should be using the dynamic routing protocol. And so if we have a circuit to go down, or the serial interface goes down, or something of that nature, then that will be advertised and notifications will be received that, hey, that route is no longer valid. You need to detour over here. So it's just like a map almost. And so what happens is, as routes go down, it gets updated and your network knows the proper way to go in order to connect to something. Okay, next, we need to NAT our IP addresses. And we're going to use, this is actually a PAT. So you should actually take a look at that, PAT. Research that on the internet, the difference between what is PAT. And so we're going to use the same IP address. That's what PAT does. Use the same IP address, but it's assigned at a different port number. So we're going to overload the address with different port numbers so that when traffic comes from different IP addresses, just give it its own unique um, port number so that you can differentiate where the traffic originated from. And so the traffic has to be netted over in order to transverse. So that's what that is for. Next one, this is our default route. So if all else fails, this is the way you should go. All traffic should go out this interface. And that is actually our default gateway. If you want to reach this particular network, or any of these, 5.1, 2, 3, 6, 7, and 254, I want you to use this interface, this IP address. Now we could actually put the interface here, which is good, because if you say, for instance, if you have to re-IP your interfaces, you would rather have that update that way as opposed to having to go back and change these IP addresses. So you can put the interface here or the IP address. And we have been logged out of the router. And as you can see, that security measure worked. So if you allow it to sit idle for some time, you get logged out. And that's what you want to happen, is if you step away, you get logged out and you're not leaving things open. And let's go back into config mode, put up space. Let's put the static routes in here. This is the dynamic routing protocol. Now we have some static routes here, as well as our NAT. We're going to add that. Lastly, we need to add an access list. So this is what this referred to. On this interface, use this list to verify what traffic can get out of this interface. Otherwise, don't let it out. And so this is what's permitted. As you can see, permit, permit, permit. So we're permitting this, 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 as well as this. Anything in this subnet, the 172.16, which is our VLAN 10. This is VLAN 20, VLAN 30, and then we're allowing anything out coming from the switch interfaces, which leading to the router. And here we're allowing the network management subnet to get out as well, so that we can connect to the various devices and make whatever changes we need to. So we're going to add that as well. Let's clear the screen once more, and let's just do just a little bit of testing. So remember what I said about DNS. So let's try ping bbc.com. And see, that was successful. So our DNS translated bbc.com to an extra IP address, and also this shows us that we can also reach the internet. So that is working. Our router is working. We have access. We are live, ladies and gentlemen. Let's ping something else. 8.8.8.8. A lot of times we want to ping, see if we can reach the internet. 8.8.8.8 successful. There are some things that you might try to ping that sometimes you get a timeout or something. But remember, everyone does not allow you to ping the devices. Sometimes ping is turned off. The ICMP is turned off. Let's try this one. So we know we can reach the internet and everything is good. Remember to use write memory or copy run start to save the config. And I'll see you in the next video. And thank you.